Good morning, students. Today I am going to discuss about the nanochemistry and application of metal nanoparticles. So my name is Dr.D.Kodimuthiri, working in BSN College of Engineering and Technology, Tirunelveli. So first about the introduction. The prefix nano. So nano is derived from the Greek word for trap. The 1 nanometer is equal to 1 billionth of meter. That is nothing but 1 nanometer equal to 10 power minus 9 meter. So we are familiar with the following matrix prefixes. So left side decimeter, centimeter, millimeter, micrometer, nanometer, picometer, femtometer, attometer. Right side dega, hecta, kilo, mega, giga, tera, beta and extra. So in this nanotechnology we particularly focus on nano. So particle size is 10 power minus 9 nanometer. Next. So what is nanotechnology? It is a new emerging technology. It is a field of applied science and technology. It includes all the branches: physics, chemistry, biology, microbiology, and all the engineering field. The main features of it is control the matter on nano scale. So nanotechnology include nanoscale designing, characterization and producing structures, devices and system by controlling the shapes and size of their application in various fields. So nanoparticles have dimension from 1 to 100 nanometer. The fabrication of particle in this range and the study of the properties. So nanotechnology is a multidisciplinary field because of all the disciplines involved in the nanotechnology. It's not only technology field, all the branches, especially science branches. So nanoscience is the study of process and the manipulation of material at atomic or molecular scale, such that properties varies considerably than at a larger scale. So mainly based on the size of the particle. The properties of the nanoparticle vary with the size. That is the beauty of the nano science. What will be the size of the nanoparticle? Compare the human hair. How much thick is your hair? So approximate size of the nanoparticle is, and compare with the human hair. The normal human hair is 0.06 to 0.08 nanometer. The average single hair diameter is 7 and 10 power minus 5 meter. When compared with the nanoparticle, a nanoparticle with 7 nanometer size equal to 10 power minus 7 meter. Thus, the average diameter of hair by nanoparticle equal to 10 power 4. The history behind the nanotechnology is the credit of inspiring nanotechnology goes to Richard Feynman, a brilliant physicist. He got Nobel Prize in 1965 in the field of fundamental work in quantum electrodynamics. According to him, he suggested the chance to build the machine small enough to manufacture objects with the atomic precision. There is a plenty of room at the room. Feynman talks, there is a plenty of room at the bottom, and an American Physical Society meeting at Caltech on December 1959. One more person, a Japanese professor, Norio was first used the term nanotechnology in 1974. According to him, according to Norio, the nanotechnology mainly consists of the processing of separation, consolidation and deformation of material by one atom or one molecule, but not in the correct sense as we use that term today. Another one scientist, Eric Texler, in 1986, he used the term nanotechnology in his book Engine of Creation. This book deals with the molecular manufacturing approach. So nanotechnology is not a new one. So already our ancient people, without knowing the nano, they are using the nanoparticles, nano materials. So mainly in Ayurvedas, they are using gold in medicine preparation, in Ayurveda medicine. There are some examples for the nano particle. Saraswatasam, it is a medicine prescribed for memory enhancement. Sarnapasma, it is the therapeutic agent for the several disorders such as arthritis, diabetes, nerves disorders, etc. Sarnabindu Rasana is a kind of nanoparticle used in the immune booster. The main ingredient of Swarna Bindu Prasana is a gold nanoparticle, cow, ghee and honey, etc. So another one is medicinal preparation for babies. Gold containing medicine preparation enhances the mental capability in babies. So paradise divided metal. So paradise divided metal represents the ruby colored colloidal gold. It's prepared by sodium iris chloride. It's treated with the reducing solution in presence of phosphorus in carbon disulfide solution. During the reaction, yellow color changes into ruby red color. So Faraday concluded that the ruby fluids very finely divided metallic gold dispersed in a liquid. He called it as a divided metal. This metal is called Faraday divided metals. Another one example is Lycurgus cup. Is one Roman vessels made up of glass. This is made up of dichroic glass. This dichroic effect is achieved by the gold and the silver nanoparticle. It represents the outstanding achievement of ancient glass industry in 4th century. Lycurgus cup appeared to be green in reflected light when light comes from the outside. The same Lycurgus cup appeared to be red in transmitter light source inside the source. The dichroism is due to the presence of gold nanoparticle and silver nanoparticle. The composition of the cup is not much differed from the modern glass. So composition is shown in the table. Both modern glass and the Lycurgus cup glass have a nearly same composition. Silicon dioxide, sodium oxide and calcium oxide. A very little bit difference between the Lycurgus cup and the modern glass. Only is silicon dioxide 73% is in Lycurgus cup. In modern glass 70%. Sodium oxide is 14%. Here 15%. Calcium oxide is 7%. Here 10%. Only few difference, but properties are totally different. Another one best example is stained glass. Artists were early adopted of the nanotechnology, however, they were not aware of the science that underpinned their work. The ruby red color of some stained glass is due to the gold nanoparticle, and deep yellow color is due to the silver nanoparticle. The size of the metal nanoparticle produced these color variations. This color variation mainly because of the size of the gold and silver nanoparticles. The gold color, gold nanoparticle and silver nanoparticles. The properties of nanoparticles. The nanoparticles are particles in the average size range of 1 to 100 nanometer. The properties of matter changes rapidly when considered it in the nano level. These remarkable changes in properties prompted the researcher to define nanotechnology as the technology based on size. Here size decides the properties of the material. The physical and chemical properties of the substance changes abnormally when changed into the nano level. Nanomaterials have unusual mechanical, electrical, optical and magnetic properties. For examples, opaque substance become transparent. Generally copper is an opaque substance. When it transferred to the nanoparticle, it became a transparent. Stable material turn combustible. Example, aluminum. Aluminum is a bulk in the form of bulk material. It is a stable one. When it bring into the nano, it became a combustible material. Another famous example is gold. Solid gold is bright yellow color. Solid turn into liquid at room temperature. Color of the gold is changed in nano size. Some insulator substance become a conducting substance. So materials such as gold, which is chemically inert and serves a catalyst at a nano scale. Size different properties of nano material. The overall behavior of bulk crystalline material changes when the diamonds are reduced to the nanoscale. The properties of nanomaterial is mainly due to the two factors. One is quantum confined effect, another one is a large surface to volume ratio. These two main properties is responsible for the different nature of the nanoparticle. Sir W. Siegel classified the nanomaterial based on the dimension. The classification based on the number of dimensions is not confined to the nano range. There are 4 types of classification based on the dimension: 0 dimension, 1 dimensional, 2 dimensional and 3 dimensional nanomaterials. First one is 0 dimensional nanomaterials. Material wherein all the dimensions are measured within the nanoscale. In 0 dimension, no dimension are larger than 100 nanometer, hence the name 0 dimension. The most common representation of 0 dimensional nanoparticle is nanoparticles. So main features of 0 dimensional nanoparticles are: it may be a amorphous, crystalline or single crystalline or polycrystalline. It may be a composed of single or multi chemical element. They exhibit various shapes and form. Exist individually or incarnate in a matrix, or to be a metallic, a ceramic or polymeric form. Next, one-dimensional nanomaterial. So, one-dimensional nanomaterial, that is outside the one dimension, that is outside the nanoscale. This leads to needle-like shape nanomaterial. So, best example is carbon nanotube, nanorods, nanowires. These are the examples for one-dimensional nanomaterials. So, main features are: so one-dimensional materials one-dimensional nanoparticle may be amorphous, crystalline, single crystalline, polycrystalline. It is a chemically pure or impure. The materials are embedded with another medium. These are the some representation of nanorods. So gold nanorods. It's a term image of the gold nanorods. The nanorod may be synthesized from the metals or semiconducting materials. Their length with ratio is 3 to 5 nanometer. So next. So two-dimensional nanomaterials. Two of the dimensions are not confined to the nanoscale. It exhibits a plate-like structures on the shapes. Two-dimensional nanomaterials includes nanofilm, nanolayers, and nano coating, so cropping seed. These are two-dimensional nanomaterials because two of the dimensions are not confined to the nanoscales. The main features are two-dimensional nanomaterials also a amorphous crystalline and made up of various chemical composition used as a single layer or multi-layer. It's a thin film. A thin film is a layer of material ranging from fraction of nanometer to micrometer in thickness. Thin film are created through the process called deposition. So three-dimensional nanomaterials, they are also known as a bulk nanomaterials. Bulk nanomaterials are not confined to the nanoscale in any dimension. In all the dimension, not in the range of nanoscale. They are characterized by having three arbitrary dimensions above 100 nanometers. Three-dimensional nanomaterials composed of multi-arrangement of nano-sized crystals. They may contain dispersion of nanoparticle bundles of nanowires and nanotubes as well as the multi-nano layers. Some examples are quantum well, quantum wire, and quantum dot. So quantum well, if one of the dimensions of bulk materials is reduced to the nano range while the other two dimensions remain large, we get the quantum well. That is, quantum wells are two-dimensional materials. So in quantum wire, two dimensions of bulk material is reduced to nano range while the other one remain large. We get a quantum wire. So quantum wire are one-dimensional material. Aspect ratio is greater than 1000 nanometer. Next one is quantum dots. If all the three dimensions of bulk materials is reduced to the nano range, we get a quantum dot. That is, the quantum dots are zero dimensional. There are different types of quantum dots. This is a cell type quantum dot, a core cell type quantum dots. How a bulk material is converted to different nanostructures? Bulk materials converted to quantum well, quantum wire, then quantum dot. Continuously change the dimension, reduce the dimension of the material. This is diagrammatic representation of bulk material to different nanostructures: bulk material, quantum well, quantum wire, and quantum dots. So overall comparison of 0, 1 and 2 dimensional nanomaterials. It's also discussed in the previous slides. The next important point is quantum size effect, quantum confinement effect. This decides the properties of the nanomaterials. The main change of properties based on size due to the quantum confinement effect and the surface area. The quantum size effect describes the physics of electron properties in solid with great reduction in particle size. Particle when reduced to the nanoscale, the properties of material changes. This effect is termed quantum size effect. It affects the optical properties, electrical and magnetic behavior of the nano material. The quantum confinement effect is observed when the size of the particle is too small to comparable to the wavelength of the electron. He describes the electron in terms of energy level, potential well, valence bond, conduction bond and electron energy bond cap. The word confinement means to confine the motion of electron in specific energy level, and quantum denotes the atomic realm of particle. The quantum confinement is responsible for the increase of energy difference between energy state and band gap. The charge carrier in bulk semiconductors can freely move in all space direction and behave as a free particle with the continuous energy level and energy density of the states. If any of the dimension is squashed such that it became a comparable to the de Broglie wavelength of the carrier or the excitation co-radiates, the motion of carrier become restricted and quantum confinement effect develop. Synthesis of nanomaterial, there are two methods. One is top down approach and bottom up approach. In top down approach, so nanoparticle synthesis from the bulk material. So bulk material converted to nano particle. In bottom up method, start from atomic level, then converted to clusters, then it converted to nano particle. From the smaller size to nano size, bulk to nano size. These are the two approaches involved in the synthesis of nano particles. In top down approach, nanomaterials are synthesized by breaking down of bulk solids into the nano sized particle. This based on the principle of dispersion. The starting materials is in the range in the solid state. In bottom up method, nanoparticles are synthesized by assembling the atom or molecule together. The starting material is either gaseous or in liquid state. So popular top down methods are nanolithography. There are two types in nanolithography: electron beam lithography and photolithography, sputtering, or plasma method. So one of the oldest technique, especially for metal nanoparticles. It involved the vaporization of bulk materials of metal and its condensation on the suitable substrate. So metal placed in the container in an evacuated chamber is heated using the high voltage RF coil. This is a diagrammatic representation of RF plasma method. The metal vapor nucleate and helium gas on, the particle diffused towards the condenser in order to deposit as a nano particle. The reacting nanoparticles are finally paciated by the introducing gas like oxygen. Another method is thermolysis. So thermolysis is a decomposition of solid at high temperature. It is commonly used for metal nanoparticles. The solid should contain metal cation and molecular anion or metal organic compounds. The material is placed in an evacuated quartz tube, is heated to decompose. The obtained nanoparticles paciated by suitable inert gases. Another method is a mechanical grinding. So diagrammatic representation of mechanical grinding in inert atmosphere. So mechanical grinding or ball milling is a top-down procedure. It is a popular method due to simplicity and relatively inexpensive in nature. So used in synthesis of different types of nanomaterial. The mechanical grinding, in this, the energy transfer to the powder from the ball depends mainly on rotational speed, size and number of balls, the time of milling, the milling atmosphere, decide the size of the nanoparticle. So nanoparticle produced by the shear action during grinding. Mechanical grinding, advantage of mechanical grinding is it's a low installation cost, low cost of grinding medium, suitably for both patch and continuous operation, capable of both open and closed circuit grinding, can be used on material of practically any degree of hardness. Another method is laser operation. This is a diagrammatic instrumentation method. In laser operation devices, typically consists of two parts. One is pulsar laser, another the ablation chamber. First one is laser ablation. So laser ablation synthesis involves nanoparticle generation using a powerful laser beam that hit the target material. Here material is removed from the surface of the surface by laser irradiation. The irradiated laser beam is absorbed on the sample surface, leading to rapid increase in temperature. In laser operation, this results in vaporization of target material into laser plane. This vaporized material may condense to form a particle or clusters. The condensed particle can be deposited onto the substrate or collect using filtering mechanism. Some advantages of laser ablation: it can be considered as a green techniques, as there is no need of stabilizing agent or other chemicals. It can be performed using both pulsed wave and continuous wave laser. Low heat transfer to surrounding. Wide range of nanomaterial can be produced. Next, top-down method. In top-down method, large scale, it is a suitable method for large scale production. In this, deposition over a large substrate is possible by this approach. Generally, chemically purification is not required in this process. So, main drawback of top-down approach: size distribution is broader, 100 to 1000 nanometer. The uniform size of nanoparticle formation is somewhat typical. Varied particle size, shape or geometry. Defect or imperfection may get introduced. Expensive techniques. Next, on the next bottom-up approach. In this bottom-up approach start from atom or molecular level to nano scale level. So nanomaterial synthesized by assembling the atom or molecule together. The starting material is either gaseous or in liquid state. These are some bottom-up method: chemical reaction, chemical vapor deposition, source cell synthesis, hydrothermal synthesis, co-precipitation. First one is a chemical reduction. It's a chemical method. This is a nanoparticle, colloidal silver, gold and copper. Nanoparticle can be prepared by chemical reduction method. In this method, we are using sodium tetraborate as a reducing agent, carried under ice cold condition to yield a nanoparticle. It's a preparation method of silver nanoparticle obtained by reduction of silver nitrate by using sodium tetraborohydrate under cold condition. We can get a silver nanoparticle. Nanoparticle of molybdenum can be obtained by reduction of molybdenum chloride solution using sodium triethyl borohydrate as a reducing agent. Next, the chemical reduction. The reduction in presence of capping agent like citrate yield a capped nanoparticle. Gold nanoparticle are produced by reduction of chloroioric acid. Chloroioric acid is converted to gold nanoparticle by using ascorbic acid as a reducing agent, citrate as a capping agent. The sodium citrate and ascorbic acid is mainly involved to decide the size of the nanoparticle. It prevents the aggregation of molecule. Next method is chemical vapor deposition. The chemical vapor deposition is a method to produce a high purity, high performance solid material. It involves the formation of nanomaterial from the gas phase at elevated temperature, usually onto the substrate or catalyst. In chemical vapor deposition, a thin film is formed on the substrate surface via the chemical reaction of chemical vapor precursors. A precursor is considered suitable for chemical vapor deposition if it has a adequate volatility, high chemical purity, good stability during evaporation. Here there are some category of chemical vapor precursors: halides, hydrates, metal carbonides, metal organic compounds. Halide like titanium tetrachloride, tungsten hexafluoride, thallium pentachloride. Hydrates like silicon tetrahydrates, germanium tetrahydrate, ammonia, metal carbonate like nickel tetracarbonate. There are so many type of chemical vapor deposition method. These are some type of chemical vapor deposition method. Atmospheric pressure chemical vapor deposition, low pressure chemical vapor deposition, metal organic chemical vapor deposition, laser chemical vapor deposition, plasma enhanced chemical vapor deposition. So chemical vapor deposition, so schematic representation of chemical vapor deposition. During the chemical vapor deposition process, the substrate is exposed to one or more volatile precursor which react and decompose on the substrate. The laser beam or plasma can be used to enhance the reaction. The volatile byproduct obtained during the process are removed by gas flow through the chamber. Next, soul cell method. Soul cell method is a wet chemical techniques that is extensively used for the development of nano material. It is the production of solid material like metallic oxide from the solution state reactant or precursor. This method is used for the development of various kind of high quality metal oxide based on nanomaterials. A soul is a colloidal or molecular suspension of solid particles or ion in a solvent. A cell is a semi-rigid mass that forms when the solvent from the soul begin to evaporate and the particle left behind begin to join together in a network. The soul cell process is a wet chemical synthesis. There are 6 processes involved in the soul cell synthesis. First one is formation of stable solution of precursor. Second, hydrolysis, next condensation, gelation, aging, and drying and densification. So first step is a formation of soluble stable solution of precursor. The precursor are the starting material and common precursor are the metal alkoxide or chlorides. It dissolves in a solvent to get a stable solution. Next step is a hydrolysis. During the hydrolysis, alkoxy group of precursor is replaced by hydroxyl group of water. Next, condensation. So condensation can be generally represented in the equation. Here M is a metal, X is a hydrogen or a alkyl group. Gelation is the process by which the soul undergo transition from liquid solution to cross-linked gel. In this process, viscosity of the solution increases rapidly during the gelation. Next stage is aging. After gelation, next step is aging. During the aging, the structure as well as the properties of the gel that will continuously change till darker density is achieved. So last stage is drying and densification. Drying is the solvent evaporation from the medium. During the densification, the product mixture attains desired density. The main advantages of solvent synthesis is smaller in particle size. It is better to control over morphology of the particle. Highly suitable for thin film deposition. It can produce highly purity nanomaterials. It can be used to produce a powder or fibers nanomaterials. Next method is a hydrothermal synthesis. It's a diagrammatic representation of here there are autoclave, Teflon cap, plastic disc, stainless steel lid, water as a solvent, and a solid reagent. Stainless steel is the main parts involved in the hydrothermal synthesis. It is one of the most well-known and extensively used method to produce nanostructures materials. Here nanomaterials are obtained through a heterogeneous reaction carried out in aqueous medium at high pressure and temperature in sealed vessels. In this process, at high vapor pressure level and using a high temperature aqueous solution, so this process is hydrothermal. High temperature and high pressure is involved in the synthesis of nanomaterial. So this process is called a hydrothermal synthesis method. So advantages of hydrothermal synthesis are it is useful for producing various nano geometries such as nanowires, nanorods, nanoseeds, nanospheres. It gives you a good control over nanoparticles shape and size. It can also be used for producing large and high periodicals having a well controlled composition. Co-precipitation method. Here require a metal cation taken as a soluble salt or co-precipitate from a common medium, usually hydroxide, carbonate, oxalates or citrate. The precipitate obtained after drying is heated to the required temperature in appropriate atmosphere to produce the final product. The co-precipitation is a simple method for synthesis of nano powder. Here iron oxide nanoparticle can be prepared by this co-precipitation method. One of the drawback of co-precipitation is it's difficult to control in the particle size and morphology. This is the problem of co-precipitation method. So advantages of bottom-up approaches. By using bottom-up method, you can prepare ultra-fine nanoparticles. So narrow size distribution is possible in 1 to 20 nanometer. It is a cost-effective method, but large-scale production is difficult in bottom-up approach. Chemical purification of nanoparticles is required. So the next characterization of nanomaterial, like preparation, so characterization also one of the most important tool in nanotechnology. So characterization is nothing but study of material features such as composition, structures and various properties like physical and electrical and magnetic etc. So with knowing the nature of the nanoparticle, we can decide the application of, we can conclude the application of the nanoparticles. Why characterization is necessary? Because the properties of nanoparticles vary significantly with the size and the shape. So accurate measurement of nanoparticle size and shape is therefore important. These are some method to characterize the nanoparticle: optical probe method, electron probe method, scanning probe method, ion particle method, spectroscopy method, thermodynamic methods. These are some characterization method of nanoparticles. So first one is the optical probe method. The primary probe is the optical method. Is a visible light of wavelength 400 to 800 nanometer. The signal from the most of the photon method is usually another photon. The photon signal from the sample arises from many possible phenomena such as scattering, emission. The optical probe method are that using light to inspect or characterize the nanomaterial. The photon generated from the nanomaterial is investigated during characterization. These are some technique involved in the optical probe method. Dynamic light scattering used to study the particle size. Confocal laser chaining microscopy (CLSM) to find the imaging and ultrafine morphology of the nanoparticle. Brewster angle microscopy, study about the gas liquid interface imaging. Scanning electron microscopy, transmission electron microscopy, high resolution transmission electron microscopy, scanning transition electron microscopy. These are the some electron probe method to study the size and shape of the nanoparticle. The scanning transmission electron microscopy is mainly used to analyze the biological samples. HRDEM analyze the image such as chemical analysis. TEM transmission electron microscopy, the image and the particle size and shape. SEM scanning electron microscopy, imaging and morphology of the nanoparticle. Another methods are field emission microscopy used to study the surface structures or molecular properties. Reflection high energy electron diffraction, study the surface structures. Low energy electron diffraction (LEED), surface or adsorbate bonding. Electron energy loss spectroscopy, study about the inelastic electron interactions in nanoparticle. Agar electron spectroscopy, so used to study the chemical surface analysis. So only study about the view of characterization techniques. One is SEM, electron scanning microscopy. So electron scanning microscopy, the images of sample is obtained by scanning the surface with the focused beam of electron. The electron interaction with the sample produces a signal that contains information about the surface morphology. In SEM, the electron beam is scanned in raster scan pattern, and the position of the beam is combined with the intensity of the detected signal to produce an image. In SEM, image formation depends on the acquisition of signal from the interaction of electron beam and its sample. Many signals are generated by the interaction of electron beam with the specimen. Each of the signals is insensitive to a different aspect of specimen and give a variety of information. So diagrammatic representation of SEM. Scanning probe method. All scanning probe microscopy method have two things is common: a finely sharpened probe tip, a system that enables the tip to scan over the sample surface. Scanning probe method, the image is obtained by moving the probe or the sample with the raster action. Resolution on this order of atom is possible. Common scanning probe methods are AFM, atomic force microscopy, used to analyze the imaging, surface structure, topology. scanning tunneling microscopy, study of the topology, imaging, surface structure. Lateral pose microscopy, LFM, study the surface friction analysis. Chemical pose microscopy, study about the chemical surface analysis. Field ion microscopy, used to study the chemical profile, atomic and spacing. AFM, atomic force microscopy. Why the name atomic force microscopy? Atomic force microscopy can achieve the atomic resolution by using the sharp cantilever tip. Image obtained by AFM can distinguish two closely spaced atoms. Then force, the image is created by the quantifying the force between the probe and the sample surface. The microscopy AFM amplify the image of the sample. AFM can provide extremely high resolution images by using an ultra small probe tip at the end of the cantilever. Cantilever made up of silicon or silicon nitride having a very low spring constant. At one end of the cantilever, very sharp tip fabricated. The cantilever scan above the surface of the sample. Spectroscopic method are also known as photon probe method. Most of this method involve a primary photon in and a secondary primary photon in and a secondary photon out. UV spectroscopy is the most common method. Two most relevant X-ray technique are X-ray diffraction and energy diffraction. So photoluminescence spectroscopy is another one method to study about the nature of the nano particles. Another one is ion particle probe method. This method involves the probing of ion or particles generated from the sample material under consideration. The most common method used this type is mass spectroscopy and modified versions. These are some type of ion probe particle and its uses. So mass spectroscopy used to study the material composition. Secondary ion mass spectroscopy used to study the composition of solid surfaces. Small angle neutron scattering used to study the surface characterization. Neutron scattering spectroscopy study the absorbed bonding chemical structures. So thermodynamic method is another one characterization method. This method includes the thermodynamic parameter. The primary probe is thermodynamic parameter like temperature or pressure. In this method, bond energy, phase change, heat capacity, surface absorption, volume change, surface tension, etc. are measured by this method. These are some thermodynamic techniques. Thermogravimetric analysis. This method used to analyze the mass loss with the temperature. Differential thermal analysis is used to study the reaction heat capacity. Differential scanning calorimeter study about the reaction heat and phase change in nano level. Nano calorimeter used to study the latent heat of fusion. Thermoluminescence, surface state trapping. So applications of metal nanoparticles. So metal nanoparticles are nano level entities made up of pure metal. The term metal nanoparticle is used to describe the nano sized metal with the dimension in the range of 1 to 100 nanometer range. The main salient features of metal nanoparticles are large surface area to volume ratio and quantum confinement as compared to the bulk metals. These two properties, surface area to volume ratio and quantum confinement, say enable unique properties of nanomaterial compared to the bulk material. Specific chemical properties due to large number of low coordination site, plasma excitation, short range ordering. Main application of metal nanoparticles. The promising characteristic features of metal nanoparticle enable diverse application. These applications include medical, biomedical, environmental, agricultural, catalysis, textiles, electronics, transportation, and many other fields. So first one is therapeutic application of metal nanoparticles. The characteristic features such as so therapeutic application of metal nanoparticle. The characteristic features such as anti-angiogenic activity and localized surface plasma resonance enable several therapeutic applications of nanometal like silver and gold and platinum nanoparticle. So treatment of different type of cancer is promising application of noble metal nanoparticles. Some therapeutic applications are gold nanoparticle, prevention of multiple myeloma. So main property is anti-angiogenic. Gold nanoparticle as a PDT agent for cancer treatment, LSPR. Gold nanoparticle for skin cancer treatment, hypothermia. Silver nanoparticle in cancer treatment, anti-angiogenic. Platinum nanoparticle in cancer treatment, anti-angiogenic. These are some therapeutic application of gold metal nanoparticles. Drug delivery, another application field is drug delivery. It's an emerging field. Generally, the aim of developing a new delivery system to ensure the delivery of drug to their desired sites in sufficient concentration while maintaining the efficiency of the delivered drug. This approach is highly useful in treatment of diseases like cancer by using different methods. Drug loader nanoparticle can be targeted towards the cancerous cell. These materials mainly include active targeting using conjugated ligand nanoparticles. It's a diagrammatic representation of targeted drug delivery. Nanoparticle loaded with the drug can be conjugated with folic acid to target cancer cell which contain folic receptors. It's a tumor site. Conventional anti-cancer formulation. This is a drug delivery method. So normal conventional method, drug involved in all the parts of the human body. But in targeted delivery system, only drug involved in the affected part only. So metal nanoparticle surfaces can be functionalized with the biocapillary polymeric materials. Example, polythene glycol to enable specific targeting of cells. Polymer functionalized metal nanoparticle are biocapillary and have a high encapsulation capacity in enabling the delivery of drug. Encapsulation of drug molecule is achieved through the electrostatic interaction or drug conjugation by means of the coating surface of nanoparticle with the polyelectrolytes or other polymers. Metal nanoparticles are biocapillary and they can be straightforwardly eliminated from the body. This emphasizes their efficiency to serve as carrier of different therapeutic drug through the encapsulation or conjugation of these therapeutic moieties on the surface of the metal nanoparticles. From the numerous viewpoints, the brain is the challenging organ for drug delivery, mainly due to the presence of blood-brain barrier. The blood-brain barrier halts the drug molecule from crossing it. It is a major hurdle of treatment of the neurodegenerative condition such as Alzheimer's and Parkinson's diseases. Metal nanoparticle, on account of their small size, have the potential to cross the various biological barrier in the body, particularly in the blood-brain barrier, which would lead to the promising treatment outcome for the neurodegenerative disorder. So So gold nanoparticles have been used as a potential delivery vehicle for anti-cancer drugs such as paclitaxel and platinum-based drug cisplatin, oxaliplatin. Another main application is protein delivery. Protein are macromolecules that exert multiple biological action in human body. They have been known to be a promising as a treatment strategy for the diverse diseases and disorders. Another one main field is gene delivery. Gene therapy present an excellent strategy for the treatment or prevention of genetic as well as the acquired diseases. A gold nanoparticle in their diverse morphologicals are potential candidate for the DNA and RNA delivery as they protect the nucleic acid and avert the molecule from nuclear degradation. In gene delivery, conjugates of oligonucleotide modified gold nanoparticles have the potential to be used for intracellular gene regulatory agent. Another one main application is tissue engineering. Tissue engineering is a rapid developing field for the advancement of medicine. It is the goal to repair the anatomic scaffold and function of missing or damaged biological organs following any injuries or pathological process by combining cells, tissues, biomaterials, etc. In tissue engineering, gold nanoparticle incorporation into biopolymers capable is an effective pathway to produce a nanostructures to deliver the growth factor and medicinal agent directly into the target location for tissue engineering application. Scaffold made up of hydroxyethyl cellulose and gold nanoparticle manifests ideal characteristic in skin, tissues, transplant engineering applications. Anti-ineffective properties. A noble metal nanoparticles exhibit different anti-infective activities. The notable activities included antibacterial activity, antiviral activity, antifungal and anti-protozoan activity. Antibacterial effect of silver nanoparticle. Antibacterial effect of silver nanoparticles have been used to control the bacterial growth in a variety of applications. Introducing silver nanoparticle into the bacterial cell can induce a high degree of structural and morphological changes which can lead to the cell death. Antibacterial effect of silver nanoparticle. Antibacterial effect of silver nanoparticle is mostly due to the sustained release of free silver ion from the nanoparticles. Diagnostic application of metal nanoparticles. Application in diagnostic. Noble metal nanoparticle exhibit profound application in disease diagnosis through the detection of certain biomarkers. Some of the diagnostic application of metal nanoparticles are enlisted in the tables. These are some nanoparticles involved in the diagnosis of diseases. Gold nanoparticles in the detection of HIV. Silver nanoparticle in the detection of pompacin, neurotransmitter, tumor marker. Palladium nanoparticle in the detection of alpha fetoproteins. Biomedical imaging. These are some nanomaterials involved in the biomedical imaging. Gold nanoparticle in the imaging of prostate cancer cells. Gold nanorod in vivo imaging of cancer cell. Gold nano cells imaging tumor in mice model. The biosensors. So biosensor are analytical device used for detection of various type of analyte, mainly biological, by translating a biological interaction by physicochemical detector within the device into optical, electrochemiluminescence, electrochemical, gravimetric or magnetic signals. Owing to the special physicochemical properties, high surface to volume ratio and the use of functionalized noble metal nanoparticles are better candidate to be used in biosensor. These are some nanomaterials used in the biosensor. So gold nanoparticle, melamine in whole milk, and gold nanoparticle in hepatitis C virus RNA. Gold nanoparticle used to sense the genetically modified organism. Silver nanoparticle in glucose in rat. These are the important biosensor nanoparticles. So biosensor metal nanoparticle in enzymology. Nano enzyme is a term used to focus on a nanomaterial with the intrinsic enzymatic properties. It has been found that simple metal oxides or metal nanoparticles have catalytic action and essential ability in scavenging or generating active oxygen species, and can take part in the enzymatic reaction, mirroring several enzymes. Enzyme in sensing and detection. Growth of pollution from industries and other anthropological activities posed a life-threatening challenges to human society in the form of hazardous pollutants such as heavy metals, ions, pesticides, dyes, toxic chemicals, pathogens, and contaminants. The various optical sensors based on metal nanoparticles have been developed for detecting the heavy metal ions. These are some metal nanoparticles used in the detection of heavy metals. Silver nanomaterial used to detect the nickel, cobalt, lead detection. Platinum nanoparticles in mercury detection. Silver nanoparticle in mercury detection. Other application of metal nanoparticles. In addition to the biomedical application, metal nanoparticles have other application also. The unique optoelectronic properties of gold and silver nanoparticles have been researched and utilized in many applications such as catalysis, photocatalysis, organic photovoltaic, sensory through water purification, cosmetics, optoelectronic devices, and etc. So finally, the main importance of nanotechnology. Nanoscience and technology are being envisioned as a science and technology of the future. The multifarious application of nanotechnology recites the remarkable features of the nanomaterial compared to the bulk materials. Nanotechnology is predicted to revolutionize every aspect of human being. So nanotechnology is helping considerably improve many technology and industry sectors such as IT, homeland security, medicine, transportation, energy, food safety, and environmental science, etc. So thank you students.